What if I told you that everything you've ever seen, every star, every galaxy, every image from the Hubble telescope, is just a tiny speck floating in a vast, invisible ocean? We live on a planet that orbits an average star, in a galaxy of 100 billion stars, surrounded by hundreds of billions of other galaxies. And yet, that's not even close to the full picture. For centuries, humans have looked up at the night sky wondering, how far does this go? Is there an edge? What lies beyond the stars? Today, scientists can finally estimate the size of what we can see. But the real question is, what about what we can't see? The true size of the universe isn't just bigger than you imagine, it's bigger than you can imagine. And once you understand why, it will change how you see everything. When we talk about the size of the universe, we need to make one thing clear. We're not talking about the entire universe, because we simply don't know how far it stretches. Instead, we talk about the observable universe, the part we can see. But here's the twist. The observable universe isn't limited by how far light can travel in 13.8 billion years. It's actually much bigger than that. And the reason lies in the fact that the universe is expanding. Let's break it down. The universe is about 13.8 billion years old. That means the oldest light we can detect has been traveling for 13.8 billion years to reach us. But while that light was traveling, the space between us and the source of that light was stretching, expanding like the surface of an inflating balloon. So even though the light has been traveling for 13.8 billion years, the galaxy that emitted it is now much farther away. In fact, according to current estimates, the radius of the observable universe is about 46.5 billion light-years in every direction. That's a total diameter of about 93 billion light-years. Wrap your head around that. We can only observe a limited sphere of the universe, not because there's a wall or an edge, but because light from beyond that sphere hasn't had enough time to reach us yet. This observable bubble contains everything we've ever seen, all stars, galaxies, nebulae, and cosmic radiation. But it may only be a tiny fraction of the full universe. So when we say, the universe is 93 billion light-years across, that's just what we can see. The rest? Still hidden in the cosmic dark. Now that we understand the observable universe, the part we can see, it's time to ask a much bigger question. How big is the universe, really? The truth is, we don't know. But we have clues, and they lead to some mind-blowing possibilities. Let's start with what we do know. We know that the universe is expanding. Not just galaxies moving away from each other, but the fabric of space itself is stretching. And this expansion is accelerating. Because of this, there are regions of space so far away that their light will never reach us. Not now, not in a trillion years. They're beyond our cosmic horizon. So, how far does it go? One idea is that the universe is infinite. No boundaries, no edges, just endless space in every direction. But there's another possibility. The universe is finite, but curved, like the surface of a sphere. Just as you can travel around Earth without ever finding an edge, you could, in theory, travel through space forever and eventually return to your starting point without ever hitting a wall. To figure out which is true, scientists have studied the shape of the universe using something called the cosmic microwave background, the afterglow of the Big Bang. And what they found is stunning. The universe appears to be flat, with only a 0.4% margin of error. That may not sound exciting, but in cosmology, a flat universe suggests it could be infinite. If it's not infinite, then it must be really, really big. In fact, one statistical study estimated that the universe must be at least 250 times larger than the observable universe. Let that sink in. If the observable universe is 93 billion light-years wide, then the whole universe could be over 23 trillion light-years across. But here's the catch. Even if the universe is only that big, we'll never see beyond our cosmic bubble. Not because we lack the technology, but because those regions are receding faster than the speed of light due to expansion. There may be galaxies out there, just like ours, with stars, planets, and perhaps even life that we will never detect. Not because they're too faint, but because the very laws of physics forbid their light from ever reaching us. So when you look up at the night sky, remember, you're not seeing everything. You're only seeing the parts that had enough time to say, hello. The rest of the universe? It's still out there, waiting, unreachable, and unimaginably vast. For all our telescopes, satellites, and simulations, one truth remains. We don't know how big the universe truly is. Science has taken us far enough to understand what we can observe and even to make bold estimates about what lies beyond. But every theory about the full size of the universe relies on assumptions, about the laws of physics, about how space behaved in the first fractions of a second after the Big Bang, and about whether those laws remain constant everywhere. What if the universe curves in ways we can't detect? What if the expansion rate isn't the same beyond our horizon? What if there are hidden dimensions or multiverses beyond our own? These aren't just science fiction questions. They are active areas of research, questions that physicists and cosmologists are still struggling to answer. And maybe we'll never get those answers. Because no matter how advanced our technology becomes, there may always be a boundary, not a physical wall, but a limit in what we can know. The universe, it seems, is not just vast in size, but in mystery. We may never know how big the universe is, but here's a thought to leave you with. If the universe is infinite, and if the number of particles, stars, and galaxies is infinite too, then somewhere out there, beyond our cosmic horizon, there could be another version of you, sitting on a planet like Earth, watching a video like this, asking the same questions. It sounds crazy, but some cosmologists think it's mathematically possible. The universe may not just be big, it may be so big, it repeats itself in endless variations. So what do you think? Is there another you out there? Leave your thoughts in the comments. And if this blew your mind, make sure to subscribe. Because the next question we'll explore is even bigger.